Hi everyone, welcome to Differential Calculus. Today we explore lesson 3.9 related rates. Number one, the idea. Imagine we are inflating a spherical balloon. So as the balloon is inflating, the radius is changing. With respect to time, volume is also changing. With respect to time, surface area is changing. With respect to time, radius changing with respect to time. If the radius is r, then this would be dr over dt. If we let v to be the volume, then this would be dv over dt. And if we let s to be the surface area, then this would be ds over dt. These rates, we call them related rates because they are changing at the same time with respect to time. So in a related rate problem, that is what we are trying to do. In step one, we sketch an illustration and label all variables that are changing at any time t. In step two, we formulate an equation to relate all variables that are changing at any time t. And in step three, we differentiate both sides of the equation in step two with respect to time t to obtain the related rate. Okay, let's try to apply this idea to do a few examples. Number two example. Example number one, a spherical balloon is being inflated at a rate of 10 cubic centimeter per second. Find the rate of increase of the radius when the radius is 10 centimeter. So this is what we need to do by dr over dt. First is we can sketch out the balloon here. Kind of like spherical balloon. This number here, it does look like change in volume over change in time. So we have two rates here. We got to relate volume to radius at any time t. At any time t. Volume is 4 over 3 pi r to the power 3, where v and r are function in terms of time. Once we have this formula, next step is get the derivative with respect to t on both sides. Apply the chain rule, so we'll have a dv over dt equal to 4 over 3 pi time derivative of r3 is 3r squared, and because of the chain rule, we'll have dr over dt. Well, it asks us to figure out d all over dt. So from here we see that d all over dt is dv over dt divided by 4/3 pi times 3r squared. And we can do the substitution now. Get rid of the 3 here. dv over dt is 10 cubic centimeter per second. You don't have to write a unit here. 4 pi. And this is true when the radius is at 10 centimeter, 10 square. So this gives us the 1 over 40 pi. The correct unit here is centimeter per second. Let's take a look at another one. In the second example, a balloon is attached to the back of a car. As the car moves, the balloon detaches and flies up in the sky. The car moves at a constant speed of 10 feet per second, and the balloon flies at a constant speed of 6 feet per second. Find the rate of change of the distance between the balloon and the car after 10 seconds. So here comes the balloon at any time t. So this distance is y. And this would be the car at any time t. So we don't know this x. The distance between the balloon and the car is this distance, called z. This is the right triangle. So we can relate x, y, z using the Pythagorean Theorem. X squared plus y squared equal z squared. From here, we can take the derivative of both sides with respect to t. And we have 2x times dx over dt plus 2y times dy over dt equal 2z times dz over dt. Simplify this to be x dx over dt plus y dy over dt equals z dz over dt. According to the question, this is what it asked us to find the rate of change of the distance between the balloon and the car. So that is we find dz over dt after 10 seconds. So we need to know what is the distance x after 10 seconds and the distance y after 10 seconds. From the information, the car moves at a constant speed of 10 feet per second. So we know that dx over dt equal 10, meaning that x is 10t. So x of 10 seconds, 10 times 10, which is 100. Similarly, dy over dt, the balloon fly up at a constant speed of 6 feet per second. So 6, y is t, and y up 10 is 6 times 10, which is 60. We have all the information here, except for z. Well, if we know x is 100, y is t, then we know z, because that is what we have. Hundred t. So we know z is root of t square plus 100 square. Yay. And so z would be root of 10,000 plus 3,600. So 10, that is 0, 13,600. Which is the same as the 10 root of 136. Now we can do a substitution and solve for dz over dt. Now we can just solve for dz over dt and do the substitution. X is 100, dx over dt is 10. After 10 seconds, y is t. dy over dt is 6. And after 10 seconds, z is 10 root of 136 dz over dt. From here, we can divide by 10. So 100 plus 36 root of 136 dz over dt. And hence, dz over dt is 136 over square root of 136. Unit here is feet per second. Awesome. Let's do a different example. Number 3, to track a rocket, a college student stands 4 miles from the launch pad. At the moment when the angle theta between the telescope and the ground is 45-degree angle, the angle is changing at a rate of 0.5 radians per second. How fast is the rocket going at that moment? Let's just sketch out a picture. This is the student. And this is the angle theta. So I mean the launch pad is right here, and somewhere is going to be the rocket. I have a right triangle right here. We know how far it is. It is 4 miles. We have no idea the height between the rocket and the ground because this is changing constantly. Now, based on this right triangle, it makes sense to use tangent. Tangent of the angle theta is h over 4. And dh over dt is the speed of the rocket. So we got to take the derivative with respect to t on both sides. Derivative of tangent is secant square angle theta multiplied to d theta over dt, because the angle theta is a function in terms of time t, equal to 1/4 dh over dt. And now we can either solve for dh over dt or do the substitution. So dh over dt here would be 4 secant square theta times d theta over dt. And do the sub here. The angle between the telescope and the ground, theta is 45 degrees, pi over 4. And then d theta over dt is the angle. It's changing at a rate of 0.5 radian per second. D theta over dt at that exact moment is 0.5. We have dh over dt is equal to 4 secant of pi over 4 square times 0.5. 4 secant of pi over 4 is the 1 over cosine. So cosine of pi over 4 is root 2 over 2. So it's going to be 1 over root 2 over 2 square times 1 over 2. Multiply this together, we have exactly 4. And the unit is mile per second. Oh, it's going pretty fast. Another example. Example number 4. An inverted conical water tank with base radius 2 meters and height 4 meters. If water is being pumped into the tank at a rate of 2 cubic meters per minute, find the rate at which the water level is rising when the water is 3 meters deep. This is the inverted conical tank. The radius has 2 and the height is 4. So at any time t, the water is filling up. And the rate of the water being pumped in is change in volume. dV over dt is 2 cubic meter per second. So that means at any time t, we have a radius and a height h here. Now, the question asked us for the rate at which the water level is rising. So that is change in height over change in time, dh over dt. We got to find a way to connect height and volume. Well, the volume formula of a cone. V is equal to 1 over 3 pi r square h. We cannot have the derivative with respect to t on both sides because we do not know d over dt. So it is best to write r in terms of h. And to do that, we're going to be using a similar triangle. Look, there are 2 triangles here. The bigger one and the smaller one. Similar triangles. Well, they have to have the same ratio. R over h must be the same as 2 over 4. So R is half of h. Then from here, V is 1 over 3 pi half of h square times h, which is 1 over 3 times 1/4 is 1 over 12 pi h to the power 3. Now we can differentiate both sides with respect to t. And we have dv over dt equal to 1 over 12 pi times 3h squared dh over dt. dv over dt equal to pi over 4 h squared times dh over dt. From here, we see that dh over dt is dv over dt divided by pi over 4 h squared. Do the substitution. dv over dt is 2 pi over 4. H is 3 squared. So that is the 2 over 9 pi over 4. So 2 times 4 over 9 pi. 8 over 9 pi. The unit is meter per minute. Pretty nice problem. Thank you for watching. I hope you found the content useful. See you in the next video.